Hello?
Is it me you're looking for?
Okay, come on, you guys are ridiculous.
Sorry.
Alright, anyway.
Say with your chest.
What?
You guys have never heard that.
What?
Say it with your chest. Okay, thank you. Thank you. You guys have never heard that?
Say it with your chest.
Pacho, are you serious?
It says Bazinga.
No, but say with your chest is like projector.
You've never
voice.
watched Kevin Hart.
No?
Oh my god.
What, am I supposed to? I thought that
Yes,
guy's in
he's
trouble
so
because
funny.
he's like,
He's
you know,
so funny.
I
Kevin
thought he was
Hart's
in trouble.
amazing.
Like no one's supposed to like talk to him. No one refers to him anymore because he got in trouble for saying something 10 years ago that he's still being flogged about.
Well, he said that like a while ago too.
Yeah, no, it was 10 years ago, but then it was like someone just brought it up recently, so now everyone's supposed to hate on him. Isn't that how things are? Social media, nothing ever goes away. All right, so like I said, I'm pretending to do some work today. All right, so we're gonna turn this right here into this formula, but I'm gonna do integration by parts, and I'm gonna make it. I'm gonna like, bam! You guys gonna be like, yes.
You sure for
See,
that one?
yeah. Can I get a witness? All right, so watch this. I told you yesterday that we have to account for all the pieces, right? So whenever we're doing this, so what should I make my u? Arctangent, right? Okay. So I'm going to say that u is equal to arctangent of x. So therefore, my du, because if it's arctangent, remember I told you guys those things, those identities, you guys got to know this. You have to know it. You have to know it. You have to know it. So, let me see. So, not you. He does?
I know.
Okay.
Said he does.
Not you. So, what would be the derivative of arctangent?
1 over x squared plus 1. Okay, I didn't know. Okay,
So just wait and be like, oh, that he was there. Yeah, it's kind of like, it's funny. My geometry class is the same thing because the way I say things, I make them repeat it over and over again. And I'm like, okay, so to find the angle, you use the, and so every time they keep saying inverse, and you say inverse. I'm like, hey, look for an angle, you use the, and they didn't know that they already know the answer. So, but I have to say it, and so that it triggers them. Okay, speaking of trigger. Anyway, all right, so du is equal to 1 over 1 plus x squared, right? And that's going to be a dx. All right, so what is my dv going to be? What is my dv going to be? I have dv, right?
Yeah.
I have to have a dv here, right? So my dv in this case is going to be what? Say it. 1 dx. Because I have to account for that piece, right? I always have to account for that piece. Whenever I'm doing this, I have to account for that. If I don't, then it's not a integration by parts. So if I'm not accounting for that, now I'm like, bam, okay, I got this. So now, what would be the integration of dv? Say v.
Oh, x.
Oh, yeah.
The integration of dv is v. The integration of dx is, okay, so for this one right here, it's going to give me my x, right? Yes? Or plus the c on that one, right? Okay, so now, for my formula, I'm going to have to start putting the things in, right? So it's going to be uv, so it's going to be x times arctangent of x minus the integration of, right, x times my dx, right? So my dx is all that, isn't it? So yeah, from du, it's right here. So for this is going to be 1 over 1 plus x squared dx. Say yes.
Yeah. But where does the 1/2 come from?
Huh?
Where does the 1/2 come from?
What 1/2?
Minus 1/2 natural log.
Bro. I got this. Give me a second, alright? Okay, did we get all that yet? Say no. No, we didn't get all that yet, right? Okay, we didn't do it yet. Okay, so I'm still getting there. So I'm gonna go from here, and I'm going to carry this over to a new page. So insert page, blank after current. So what do we say? X times arctangent. Man, mouth work. Okay, minus integration of x over 1 plus x squared dx. Now, I'm going to say I don't like that. I do not like it here or there. I do not like it anywhere. Right? What part of that do I not like? Is it a quotient? Say yes. Is it a quotient? That is a quotient, right? So I have stuff on the bottom, don't I? If I have stuff at the bottom, what do I want to try to do that?
Make the derivative equal to top.
Like a u sub type thing, right?
Oh,
To do the integration, I want to u sub this. Okay, but I'm already have a u and v in this, so I'm gonna t sub this. I'm just making up variables as I go because I'm subbing for this because I would say u sub, right? What would I u sub to make this problem easier? The 1 plus x squared, right?
Yeah.
So let's do that. So let's say that my t, because I'm t subbing it because I already have u as a variable. So t is equal to 1 plus x squared. So my pen's running out of ink. dt equals 2x dx, right? Yes? And so when I do this, I'm going to divide both sides by 2. So now let's u sub this back in. When I u sub, what's going to happen to my x and dx? That goes away, doesn't it?
Yeah.
So the x and the dx both go away because I'm u subbing that and I'm putting in my dt over 2, right? So that's just basically 1/2. So I'm going to rewrite this. So it's x times arctangent of x minus the integration of, I'm taking away all that. So now it's just going to become 1/2 times, I u subbed the whole bottom, right?
Yes.
So what am I going to replace that with? 1 over 1 over t dt, right?
Yeah.
Did I lose anyone on any of that? You guys, please speak up, because this is some craziness right now. About ready to get a whole bunch crazier. Yes?
Wild.
Wow, we're getting wild.
We're getting
We're getting buck wild. All right, so it's going to turn into x times arctangent of x minus 1/2 integration of 1 over t dt. Now, what is the integration of 1 over t?
Natural log t.
Ln t, right? Ln t. So it's going to be x times tangent of arctangent x minus 1/2 ln of t, right? Ln of t plus c. But now, I t sub this, right? Say yes. So now that I t sub this, I got to do what? Put the t back in. Let's put the t back in. So it's going to be, the x back in. X times tangent, arctangent, sorry, of x minus 1/2 ln of 1 plus x squared plus c. That's where my 1/2 came from. Hey, you asked me where 1/2 came from.
No,
It's right there now.
I got it from the.
Hey, look, it's
I
there.
got it from the x squared.
Yeah, okay, good. Does that make sense, you guys? Okay, so these are identities and a lot of the stuff that we've been just putting on your flashcards and saying, hey, remember this. Remember this. This is important. This is important. So all the AB topics Or like, oh yeah, you should know that one already. You should know that. Okay, it came from BC stuff, BC proofs. All right, right here. Find this one. All right, so you guys, tell me what my u is. Say it.
X squared.
Okay, so u is x squared. So du is 2x dx. Okay. So now let's do, so my other piece is going to be what? My dv. dv is equal to e to the x dx, right? So I get v is equal to e to the x, right? Yes? Okay. So we get this. So now let's go ahead and start putting stuff together. So I have x squared e to the x minus integration of, what's that going to be? E to the x times 2x dx, right? All right, can I factor out a 2 from there? Say yes. Yes, I can factor out 2. So I'm going to factor out 2, so now it's going to be x squared e to the x minus 2 integration of x e to the x dx. Okay, what did I just do there with that? By doing that, what happened? I still have an integration that has a product rule, right? I still have it. But now what did I do by doing what I just did? Is it x squared still?
No.
No, it's not x squared anymore. It's now x to the first.
Yeah.
So in this one, my u, by doing that, I'm actually lowering the degree of my u. So sometimes I might have to do this more than once. Here's the case. So if I do the integration again, what do you think is going to happen to my u value? My x is actually going to go away, right?
Yeah.
That's what I'm trying to work towards. So this is going to be a problem in which that I would actually do this part again. So I have this front part right here, which is going to stay, and then I'm going to make it a u, okay, and dv over here, right? Make sense? So just so happened that we've already did this problem. Right there. So, yeah. So without actually having to redo and actually keep going back over again, I know that piece right there is going to be what I need, right? Yes? So for my integration, I'm going to carry that back over. Okay? Just because for the sake of time on this one.
But you're saying there might be problems where you need to integrate by part and then integrate by part again to lower the degree. That way you can break it up.
Yes, exactly.
Okay.
That's what we're going to do. Okay? So now we have that.
Yeah. It's like, it does not
Okay,
exist. Oh,
so
nice.
again, I'm taking it, so it's x squared e to the x minus 2 times. Now, what am I carrying over? What did I carry over from that first example?
The integral.
So it's going to be x,
E to the x.
x e to the x minus
E to the x.
e to the x, right? Plus c. Now, the reason why I put c outside is because I took the integral over here, right? I took this integral, right?
Yeah.
So this one's going to add my c, but I just did all the math on a different page and just used that one right there. What do I still have to do? That 2 is going to distribute into there, isn't it? But either way, that's still the right answer. I can distribute that 2 or just leave it like that. Does that make sense? Is that like, bam, right there, got this.
That's how you leave it though?
Yeah, you can leave it like that. I would leave it like that. Do you not want to leave it like that? Do you want to expand it and factor it? Because we could do that too. What can we factor out of all of that?
EX.
Okay, let's do that. So it's going to be e to the x, right? So it's going to be an e to the x times the quantity of x squared minus 2x plus 2
2, yes.
plus c. Right, because I'm distributing the negative 2, right?
Yep. Yeah.
Okay, hey, look at that. Now, can I factor that? I can factor that even further.
Oh my God.
But wait, there's more. If you order the next 5 minutes, I will slap this student in the first roll just for the fun of it.
The top 10 students.
Okay, are we all right?
Birthday, Mr. Pacho.
Yeah.
That should be your birthday present.
Go for the hot wings. Suppress this enough.
Okay, so now, see all this right here? Es muy importante.
Oh,
Now, why do you think it's important?
Wait, is that what that is? Wait,
It's a table and it tells you where and why. What piece you're going to use for your U, what piece you're going to use for your dV. Okay, these are actually important. So, whenever there is an arc sine, arc tangent, arc cosine, you want to use that as your U because you know the derivative of the arc sine, arc cosine, arc tangent, because I told you guys we have to actually go over that. Those are things you guys have to know. Those are important. Okay? So those are going to use for your U, and that means that takes out that whole piece of that. And so you're just integrating the other piece. Right? Makes life easier. All right. What do you think this time?
I'm not.
What's my U? So it's going to be U equals e to the 2x. Because I said that, it's got to be the arcs, right? You want to use the arcs for the U, right? So this one's not an arc. So it's going to be U is equal to e to the 2x, right? So du is equal to, what's the derivative of e to the 2x? 2e to the 2x, right?
Yeah.
Okay, so dv
Yes.
is going to be cosine of 3x dx. So v is equal to, now we have to integrate that piece. Now, this is one of those ones that annoy the crap out of me. Because for some reason, this never sticks in my brain. It never sticks, and I have to redo it every time because I know I'm foundation in derivative. But integration is the antiderivative, and I have to try to verify it because for some reason it doesn't want to stick. So, because there is a 3 inside that 3 with the x. That is inside. It's like a chain rule for that. Okay, so we're going to take care of that piece. Okay, so again, that would be like a U sub on this case, right? But I'm only going to U sub my inside part, right?
Yeah.
So if I U sub the inside part and just call that a U, right? What would du be? 3, right? Okay, so if I call that U, so it'd be 3x is my U. My du is 3 dx divided by 3. Okay? So then I could actually, the cosine, so integrating cosine is going to be sine, right? Sine. And so when I do that, it's going to be sine, but then what do I have to add to that sine? 1/3. 1/3 sine of x. Or, in this case, 3x. I'm sorry. The U sub, got me again. All right. Every time, I have to try and think of it like that, or every single time that when you do that right here, what's up?
Dx on the left side too. Du equals 2 dx.
Oh, Thank you, thank you. dx. All right, good. All right, so now with that information right there, I now could actually do what I need to do here. So let's throw them in together now. So my uv, so it's going to be, crap, that's ugly. Let's say 1/3 e to the 2x sine of 3x minus integration of, okay, so it's going to be 1/3 sine of 3x times 2e to the 2x dx.
Oh, that is really.
But wait, there's more.
Pull up to 1/3. Have we done the problem?
Pull out a 2/3?
Yeah, 2/3.
Pull out a 2/3.
Yeah, 2/3.
Okay.
But then it just brings us back to the beginning. But with a sine instead of a cosine.
Yeah.
You gotta integrate it.
No,
Yeah,
well,
we
You gotta
gotta
do
lower
those.
that.
Oh, really?
there is no way you can integrate. It's because it's a circle, that's why. Just destroy all circles.
You guys will love this one.
Equals 1.
It was just an identity, you just had to know that.
Oh, yeah. Yeah, what even was it?
Wait, but how did the first? Nope.
No, it's just it equals 1, sorry.
So if we do that all again, we have all this stuff on the left side, plus some more stuff in the middle. e2x negative cosine x 3x. Just keep going. We just keep adding more stuff to the outside, and it just keeps going up this way.
Just break it down, you know?
Is there gonna be a problem like this in your reactions?
Probably not. So this one right here,
Should you flip the u in the v?
this one, no, it's fine. You have to do it a couple times.
How many times is
You know, at least.
I'm actually counting it right now. So it's 1, 2 times. So you keep going, and then when we get to a certain point, we could actually go back and say, hey, you know what? I already have the value.
Oh, makes sense. I know what the integral of e2x cosine 3x is.
You
It's
should
all
get your flashbacks when you do this problem and know
Wait,
that-
but then wouldn't it just take all that and put it there?
Okay, so because we said that this is going to be a issue because this thing doesn't go away, does it? Every single time, because that e to the 2x is going to give me an issue every single time, right?
Yeah.
So I gotta try and figure out, crap. I gotta try and figure out a way to actually keep doing it. So I can keep doing it, and it's eventually gonna come out to something that I've already have, and so I could actually subtract it from what I did, and I'm end up with something. It makes sense.
Right.
So if I add another integration that is this exact same thing, won't it cancel itself out? So if I'm adding the same integration again, I'm eventually going to cancel this piece out. So the whole integration is just the coefficient is going to be different. Coefficient is going to be different. And then it will cancel itself out. But, okay, it's one of those things that you're like, crap, gotta do it again, do it again, do it again. Oh, there it is. Now, let's try it using the other way. Let's say u is the cosine now. Okay, because I can actually do it both ways. And let's see if that actually helps me out. Okay, so if I do that, insert page right here. So it was the integration of, was it e to the 2x, right?
Yeah.
Co- Let's say u is equal to the cosine of 3x. So du is equal to 3, my negative sign,
There's
so
your problem.
negative 3 sine of
There's your problem.
3x, right?
DX.
My v, yes, thank you, dx. My dv is equal to e to the 2x dx, right? So my integration of this, okay, so it's 1/2, very good. So it's going to be v is equal to 1/2 e to the 2x. You guys agree? Or did I do that piece too quick? Do you guys like the integration of e to the 2x? Is that okay? No? Maybe.
No, it's
Sleepy, grumpy, dopey? Are we okay? I just u-subbed it, basically. I said e to the u is that, and then I plugged it back in, right? Where you get the 1/2? I just u-subbed the 2x.
yeah.
Okay, good. All right, so let's go ahead and do that one now. So now it's going to be uv, so it's 1/2 e to the 2x times cosine of 3x minus integration of 1/2 e to the 2x times,
-3.
yeah, okay, so my -3 sine of 3x dx. Okay, go through, see what we get. Okay, it's going to come out, this piece going to be a negative, right? So it's a negative, positive, so that makes that a plus 3/2 this. So 1/2 e to the 2x cosine of 3x plus 3/2 integration of e to the 2x sine of 3x dx.
So, yes. Could we set that side equal to the other thing that we got?
No,
Against
because from the use of, either way, it's going to come out doing the same thing if you use one, whichever you used as your u value. You're still going to have to come back and actually, do it again, and then try to keep doing it. I think this one does like 3 times. Well, I wanted to show you both ways where you're going to have to eventually get down to there. Okay, those are going to be some of the harder ones, but I'm trying not to give you too many of those. Okay, so I think there's only 5 problems on your homework today. Wait, plus your AP questions. Anyway. All right, so either way, you have to keep going. They cancel. I just want to, before the time runs out, get to the next part. All right, so. Okay, definite integral.
Oh, wait,
Yes.
so then what do we do with that?
You would have to keep going. I'll go back over it later. Okay, I'm just trying to finish up the notes.
Oh,
Okay. So I'm just showing you both ways you're going to get the same thing. Okay. So for definite integrals, okay, find the indefinite integral, use integration by parts, then the fundamental theory of calculus. Okay. So same thing. Okay. Or method 2. Find the definite integral directly by using the limits of integration at each step of the process. Therefore, it would be like this. So you would plug into my uv from a to b minus my integration from a to b. Does that make sense?
Yes.
Okay. Yeah? Okay.
so it doesn't matter which method you use? Or does
No, it doesn't. But this one right here is a bit easier, I think. Using this straight away, and then right here. Just plug it in for each piece from your bounds. So what's my u here? X. So u equals x. Du is equal to dx. dv is equal to secant squared x dx. So v, come on, v is equal to what? What is it? Tangent. Tangent of x. So I'm going to end up with x times tangent of x from 0 power 4 minus the integration from 0 power 4 of tangent x, and that's going to be dx, right? All right, so it's going to be pi over 4, top minus bottom. So it's pi over 4 times 1, which is pi over 4, minus 0. So this piece is pi over 4, right? Yes? No? Did I confuse you? Am I losing anyone? Because that guy over there is falling asleep.
No, I'm nodding.
Do you agree? Pi over 4.
I'm shaking my head.
You guys, yes? Okay, because it's pi over 4 times 1 for my top bound. My lower bound would be 0 times 0, which is 0. Okay? Minus, okay, it's going to be secant squared, right? So it's secant squared of x from power 0 to power 4, right?
Wait, what?
Is it really?
Wait.
Wait, no, it's not. Oh, crap.
Yeah.
Oh, sorry. Thank you.
Hello?
Thank you. I know. All right. What is the integration of tangent? Because yes, we had that one the other day. It was on the notes. Integration of tangent.
Negative ln of cosine.
Cosine of x?
The absolute.
Absolute value of cosine x, like that.
Oh yeah.
So, you guys remember this or no? Am I blowing smoke? We had this one recently. I gave you guys all the integration, and it was on 7-1, and it was it part of this? Actually, it was part of this. So integration, yeah, it's secant, not cosine. It's secant, not cosine. So it's going to be ln of secant x plus c. And yeah, and it's going to be from pi over 4, from 0 to pi over 4, right? Did I include it in this set of notes? No? It's not in this set of notes?
It was just the integration of arc 2. Wait, yeah.
Okay, if anything, I'll add it to the next set. Okay, it's part of this one right here anyway. Alright, so from there, secant at pi over 4. What is secant at pi over 4? ln of, so secant's the reciprocal of cosine, right? And cosine at pi over 4 is rad 2 over 2. So flip that over. So it's going to be 2 over rad 2. And when we rationalize it, it just becomes 2 square root of 2 over 2, which is just square root of 2. Very good. Square root of 2. Okay. Minus. Okay. My lower bound. What is cosine at 0? 1. What's the reciprocal of cosine? 1. Still get 1, right? Absolute value. Okay, and plus C. Okay, those flashcards, you guys. Flashcards this weekend. There might be a pop quiz beginning of the week on trig integration. Yes.
This is definitely the C or
No, yeah, you're right. Sorry. Thank you. All right, I don't
Oh,
know.
I thought the C would be coming from the other.
No,
Integration.
no,
But
it's
you're right,
not.
yeah.
Sorry. Thank you. Okay, you have done so well. I will give you a cookie.
Nice.
You have done well. Good job.
That was a beautiful catch.
Okay. All right. So I'm gonna leave off on this today. I'm gonna leave off on this. I'll probably gonna try and finish this up tomorrow, but we really gotta work to try and get the rest of these in. So I've already assigned you guys all the homework for this section already, but there's like I think there's 2. Oh crap! This one has 10 examples. Okay. So I'm gonna do my best to try and get through everything tomorrow. Okay. All right. Like, share, subscribe.